I prepared this short video to go over volumetric glassware and to let you see what our Vernier equipment looks like and how we're going to be using that to perform spectroscopy on the methyl red. Volumetric glassware is needed when volumes of liquids need to be known precisely. We will need to know the concentration of the methyl red solutions to 4 significant places, so we will use a 100 milliliter volumetric flask and a 10 milliliter volumetric pipette in this experiment. Here's our volumetric flask. And you can see that there's a score on the neck of this volumetric flask, so we're going to want to fill this flask ultimately to where the bottom of the meniscus is resting just at the top of that score. Here's our 10 milliliter volumetric pipette. And as you can see with this one, on the neck of the pipette there's a score, and we're going to draw liquid up into this pipette, and then we're going to drain the liquid out until the meniscus, again, is the bottom of that meniscus is resting right on the top of that score. So we're going to draw the liquid into the pipette with this pipette bulb. We're going to squeeze the bulb, set it on the volumetric pipette on the top of that pipette, and then as we release the pressure from that bulb, it's going to draw liquid into the pipette. Okay, so we're squeezing the bulb, setting it on top of the pipette, and then when we release the pressure from the bulb, it draws liquid into the pipette. When the volume gets above that score, we're going to take the bulb off and we're going to put our index finger on the top of the pipette. And this stops liquid from draining out, but if we can release just a little bit of pressure with our index finger, we can slowly let the liquid out of that pipette. So we went a little bit too far that time, so we're going to draw up some more liquid. One more time. And here again, if we slowly release the pressure with our index finger, we can let the liquid drain out really slowly, and then we can press firmly with our index finger when we get right to where we want the level to be. So there you can kind of see that the meniscus is right at the top of that score. Then we're just going to put that into our volumetric flask, and we're going to release our index finger and let the liquid drain into the flask. When the liquid is completely drained, we're just going to touch the tip of that pipette to the side of the flask to let the last drop of the liquid into the flask. Okay, so now we're going to make that acidic with some HCl. We're going to add 10 milliliters of an HCl solution. We don't need to know this precisely, so we'll be able to use a graduated cylinder in this step. Okay, so now we just need to bring that flask to volume with deionized water. So we're going to slowly pour water into the flask until we get just below that score on the neck of the flask, and then we're going to use a medicine dropper to get it right to the mark. We're going to invert that flask a few times and make sure everything is thoroughly mixed. We want to make sure that that cap is securely on the top of the flask when we do this. Okay, so now it's time to look at our Vernier SpectraVis, and this is what we're going to use to obtain our spectral data. So the first thing that we're going to do is we're just going to connect our SpectraVis to the computer with a USB connection. And then we need to take a blank of our solution, so we're going to fill up a cuvette with deionized water. And if you drip water outside of the cuvette, you should wipe that off with a chem wipe. But we're going to put our cuvette with the water into the SpectraVis. And now we're going to open the software to be able to do our spectroscopy. So we're going to double click on this little Logger Pro icon here. This is going to open up our program, our software, and with the SpectraVis plugged in, the software automatically recognizes that we've got our spectrometer plugged in. So the next thing that we need to do is calibrate the spectrometer. So we're going to go to Calibrate Spectrometer 1, and we're going to get a so it's going to tell you that it needs to warm up, so we're going to let that warm up. When the warm-up period is done and we have our cuvette with water in the spectrometer, we're just going to hit Finish Calibration and hit OK. And so now we're ready to collect data on our solution. So at this point, we're going to take that cuvette and dump out the water, and we're going to fill the cuvette with our solution. At this point, we're probably going to want to fill it up once and then dump that into a waste beaker and then fill it up again. And this ensures that we have the right concentration in there and we're not diluting it down with drops of water or another solution. So at this point, we're going to put that into our SpectraVis. And we're going to go back to our program and we're going to hit Collect Data. And you can see that we've got a nice absorption spectra of our methyl red. So we're going to click this button up here and we're going to click on the absorbance versus concentration, and we're going to choose what wavelength we want to look at. And at 519, around 520, we're going to click on that. And then you can see the absorbance at 519.8. We can say 520 is 1.3. It's kind of bouncing around here. You might want to let it level off, but that would be the absorbance that we would record for this solution at 520 nanometers. So then when we're done collecting that, we can switch that to 420 nanometers, and then we can record the absorbance at 420 nanometers. So this was just kind of an introduction to let you see what our Vernier equipment is like. And you will have another step in this experiment where you're going to take the pH of each of your solutions, and we can just read through the instructions for that to be able to do that. And I would recommend that you go into Canvas, and Appendix 6 is for Vernier equipment. it would be a good idea to print this off and bring this to lab with you. It would just be a lot easier to work through this program if you have instructions in front of you. And so that's it for this video.